The problem is using Thevenin's theorem, find the current through resistance R connected between points A and B in the given figure. So the figure which is given at the right hand side. So between the point A and the B, the 10 ohm resistance is connected. So the question is saying, by using the Thevenin's theorem, find the current passing through 10 ohm resistance. So this is the question. Now, when we use the Thevenin theorem, the first step is remove the load. The first step is remove the RL, remove the load, and make the new circuit. And here, so it means, so this we have to remove from here and make this as a open. So now you can see the circuit which is given at the left hand side between the A and the B. There is nothing, but here you have to find the Thevenin voltage between this open point. So between this and this you have to find the Thevenin voltage by using any rule, by using the superposition theorem, by using the mesh method, by using the KCL or the KVL, by using any method. You have to find the value of the Thevenin voltage between A and point B. So basically, if I go to the circuit, this voltage is coming between from here to here. This voltage is coming from here to here. So it means this voltage is the sum of 45 volt plus the voltage across 10 ohm. So how much voltage is coming across 10 ohm? This is the Thevenin voltage. What is it is coming from the circuit? So the Thevenin voltage is equal to the 45 volt plus minus depends upon the direction. So here we are writing plus, and the voltage across 10 ohm resistor. So one voltage already it is known to us. So we don't know what is the voltage across 10 ohm resistor. So if I able to find the current here in this 10 ohm resistor, easily I can find this value. So we can find the value of the Thevenin voltage. So now if I look at the loops, say this is loop number 1, say this is loop number 1 and this is loop number 2, and in the loop number 1 the direction of the current is flowing like this. Say it is I1. So and the loop is moving clockwise direction. The loop is moving like this clockwise direction, and this is also the direction of the current. Now let's say in the loop number 2 the direction of the current is like this, and say this is I2. Now if I say this point, the X point, and this point, if I say the Y point, so how many components are between this X and the Y point? Two resistors are connected in series. So in this series resistance, no single current is passing, no single current is flowing. The difference or the sum of the current is passing, maybe I1 minus I2 or maybe I2 minus I1, like this way. So there is a method of this kind of problem which you have to take. Now see here, very careful. Now this is the direction of the current, and the direction, and in this loop we are moving in the same direction. So the current is moving like this. This is the direction of the current. If I see from the loop 1, so in the loop 1 apply the KVL. So now here the direction of the voltage is this, and here the direction of the voltage is this, and here this I1 it is passing from this 15 ohm also, it is passing, the direction of the current is I1 from 15 ohm, it is like this. So now in the loop number 1 we start from here. So this is the direction of the loop, so the direction of the loop and the direction of the voltage, they are same, so we will take the plus sign, so this is plus 45. Now this loop will come near this 120 volt source, so the direction of the loop and the direction of this voltage source, they are opposite, so we will take the minus sign and it is minus 120. Now this loop is coming here, so now see this loop direction and see this, the direction of the current, they are same, so it means it is minus sign, so this is minus 15 I1. Now, so from here, when this current will come here, when this current will come at this point, so the current will divide, some current will go here and some current will go here. Now this current, this I2 current is coming here, like this is I2 current, is this I2 current is coming here, so and this I1 is passing from here, so this I1 is coming like this and this I2 is coming like this from here, but we are applying the KVL rule in the loop number 1. So from the 5 ohm resistor, the current passing is the difference of I1 and I2. The current passing from 5 ohm is, this is I1 minus I2, not I2 minus I1, because this loop current will come first. So here this is I1 minus, it is I2, and here, because if you see that here we have to see the direction of the loop current, so the direction of the loop current is this, so this is I1, the direction of the loop current is this is the loop current, and the loop is also going like this, so this is the loop direction, this is the loop direction and this is the direction of current, so both are have the same direction, so it will come minus sign here, minus, and it will come 5. Now we will come to, okay, so the loop direction will come here, the loop direction will come in front of 10 ohm, so from the 10 ohm, the I1, see the direction of the I1, what you have to see, you have to see the loop direction of the loop current, so this loop current from this 10 ohm, it is passing like this, and from the opposite side the I2 current is coming, so the meaning is, in the 10 ohm the difference of I1 and I2 is passing, so the difference is I1 minus I2 or I2 minus I1, so the rule says the first the loop current will come, so I1 it will come first, and then it is minus I2, and here it is minus, because this is the loop direction and this is the direction of the current, the loop direction current, so they are same, so here it will come minus 10 and this is equal to 0. Now if I solve this equation, so this equation will come, this is 30 I1 minus 15 I2 equal to minus 75, and you say this is equation number 1. Now we have to work in the loop number 2. So this is loop number 2, and we assume the current passing in this circuit is like this, so this is the direction of I2 here, like this I2 is passing like this, this is the direction of the I2 current, like this. So this direction is very important here, and I am moving in the loop. So this is the direction of I2 and this is the loop direction. So both I have taken same like this. So this is very important in this type of question, the loop direction and the direction of the current in that loop. So this is loop 2 and the current is moving like this. So this is the direction of the current and this is also the direction of the loop. I am also moving. So this I1 is this I2 for the loop 2, this is I2. So this I2 is moving in this direction. So this is our main direction here. Now if I see the 10 ohm resistance and here in this loop, in the loop number 1, the current passing is I1. So from this side the current is passing I1 and from this side the current is passing I2. So when we are in the loop 1, we take the current I1 minus I2, from here. From 10 ohm we take this I1 minus I2 like this, and from here also we take this is I1 minus I2. But if we are in the loop, so here the difference, if I apply the KVL in loop number 2, so in the loop number 2 the current is I2 current is flowing, so that is the main current. So here from the 10 ohm, so the current passing through 10 ohm is first the loop current, then minus the other current. So first you have to always take the loop current first, then the other current, the current which is coming from the other loop. So same as for the loop number 1 also. Now the current passing from 5 ohm, same like this. Okay, so this is I2 minus and this is I1. Now we can apply so we can start from here. Okay, from the 5 ohm. So here the current passing through 5 ohm, it is like this. So this is the direction of the current in this 5 ohm, I2, and this is the loop direction. So they are in the same direction. So it means this is minus and it is 5I2. Now this loop will come here. So here it is, the direction of the voltage is this one. So the direction of the loop and the direction of the voltage, they are same. So it means it is plus and this is 20. Now this loop, it will come here near the 10 ohm. So from the 10 ohm the current passing is, this is I2 minus I1, and here it will come, this will come 10. So this is the voltage, but what sign will come? So what you have to see, this is the loop direction and the I2, this I2, you have to see the direction of the loop and the direction of the loop current. So the direction of loop current is this. So here this and this, they are same. So it means it is the minus sign will come here. Now this loop will come here, and this is the direction of I2. The I2 is passing here like this. I2 is passing here, and this is the direction of the current, and this is the direction of the loop. So they have the same direction. So it will come minus sign, and the current, it will be, this is I2 minus I1, and it is multiplied by 5 ohm. So here the minus will come because it is in the same direction. So this is equal to 0. So if I solve this equation, So this equation will be, this is minus 15i1 plus 20i2 equal to 20. So this is the equation number 2. So now the equation number 1 and the equation number 2 are the simultaneous equations. So if I solve the equation 1 and the equation 2, so I will get the value of I1 and I2. So here this I1 is coming equal to minus 3.2 ampere, and this I2 current is coming equal to minus 1.4 ampere. So these are the two currents we got. Now from the last slide, what exactly I need? I need this much circuit. So I am redrawing this circuit here. So this is 45 volt supply, and this is point A, and here this is 10 ohm, and here there is a point A, and this is point B. So here we have to find the voltage. So if I say the voltage across A and B, so if I say this voltage is AB, let us suppose, and now if I take this 45 volt as a, here there is only one voltage source, I want to apply the Kirchhoff's law here in this portion of the loop. So if this is plus here, minus here, so I am taking plus sign here and the minus sign here. So this is minus sign here and plus sign here. So the direction of the voltage across 10 ohm is this, and the direction of voltage AB is this, and the direction of 45 volt is like this. So in this loop I want to apply, so you say the I current is here actually the I current is passing, but the I is the sum or the difference of the two currents. So this is we have taken, this is loop number 1. So in the loop number 1, the current passing through 10 ohm is, this is I1 minus I2. So this current we have to take from the 10 ohm. Now if I apply the if I apply the KVL in the loop, so this is 45, so this direction and this direction same, so this is 45 here, and now the loop is coming like this, so this direction and this direction, they are opposite, so it is minus VAB, and now this is coming here, so this direction and this direction, they are opposite, so it will be minus 10, and this is I1 minus I2, and this is equal to 0. Now already we got the value before. The value of the I1 is, this is minus 3.2 ampere, and the value of the I2 is, this is minus 1.4 ampere. From the last slide we got this value, and you put this here and put this here. So after putting this, we will get the value of VAB, which is equal to 63 volt. So this VAB is equal to the Thevenin voltage. Now the turn is for Thevenin resistance. So this Thevenin resistance you have to find. So to find this, if any voltage source is there, so the voltage source you have to make it short, and if there is a current source, then you have to make it open. So it means here this is short from here, this is short, so there is no meaning of this. So it is shorted from here, so there is no meaning of this. So it is shorted from here, so there is no meaning of this 20 volt. So now if I redraw the circuit again, so this in some simplified form, so this will come like this. So here this is the 10 ohm resistance between A and B, then there is a 5 ohm resistance, and here this is 15 ohm resistance, it is coming here like this. And if I go down, so here it will be 5 ohm resistance like this. So this is the 10 ohm resistance, and this is 5 ohm resistance here, and this is 15 ohm resistance here, and this is 5 ohm resistance here. So this is 5 ohm resistance here. Now we have to find the total resistance across this and this point. So you have to understand the type of the circuit. So where there is our parallel circuit and where there are the series circuit, so this you have to find here. And if you look at the 15 ohm, this, if you look at this 15 ohm here and this 5 ohm here, so both of these, they are connected in parallel. So if I solve this parallel portion, so this parallel portion is, this is 1 over, this is 1 over 1 over 5, and this is 1 over 1 over 15. So after the calculation it will come 3.75 ohm like this. Now if I redraw the circuit again, so the circuit will be like this. Here this is 10 ohm resistance here, it is 10 ohm, and this is A point and this is B point, and here this is the 5 ohm resistance here, and then this what we calculated parallel, so it will come the parallel to this, it will come the parallel to this, the parallel from here to here. So the parallel from here to here means this one. So this resistance is equal to, it is 3.75 ohm. Now look at this circuit. So you have to find the resistance across this and this from here to here. So now this 5 ohm and this 3.75 ohm, they are in parallel, sorry, they are in series. So if I redraw the circuit again, so it will be like this. So here this is the 10 ohm resistance here, and here it will come, this is 3.75, and here it will come this 5 ohm, and it is like this. So here this is A and this is B. Now these two resistance, this 3.75 and this 5 ohm, they are in series, and this series is parallel with this one. So after the resistance, if I calculate the resistance between A and B, so this is equal to this 10 ohm plus 1 over, sorry, this is not like this. So if I calculate the resistance between A and B, so this will be like this, the resistance between the A and B, this is equal to 1 over, and this is 1 over 10, and this is plus 1 over the sum of this and this, so this is 8.75, and this will be equal to this is RAB is equal to, it will come 4.6 ohm. After the calculation it will come 4.6 ohm. Now you have to draw the Thevenin's equivalent circuit.